All right, and we are recording. All right, so we are on module 6, software and hardware assurance best practices. Service-oriented architectures. We went over a little bit of this in the last module. Several software assurance best practices are related to SOAs. Security Assertion Markup Language, or SAML. Simple Object Access Protocol, SOAP. Representation State Transfer, REST. SOAs are interfaces that use common communication standards to allow easy and quick incorporation into new applications without the need to perform complex and deep point-to-point integration each time. Each service combines or embodies both the code and necessary data integrations required to execute a complete and discrete business function. All right. Now this is actually a really good graphic here. So traditional architecture, as you can see, it kind of goes spaghetti all over the place once you get towards the bottom. So you have your service scheduling, check customer status, determine product availability, order processing, check customer status, determine product availability, verify customer credit, order status, account management, calculate shipping charges, order status, check credit. And as you can see, it just kind of goes all over the place to the different data repositories. When you use the service-oriented architecture, you have everything kind of put out in blocks there so that it's a little bit easier for things to find what you're looking for. Advantages: improve business agility, leverage legacy functionality, and enhance collaboration. I think one of the reasons it enhances collaboration is it's easier to find stuff. Because if you've ever dealt with one of those legacy systems, it's kind of a pain and it takes a lot of time. And then you have people that are getting short-tempered, and it's really hard to have good collaboration if you're angry about stuff. SAML, or Security Assertions Markup Language, an extensible markup language standard that allows secure web domains to exchange user authentication and authorization data in an SOA. Used extensively for online e-commerce, business-to-business, and business-to-consumer transactions. All right, so if you go 1 through 8. User attempts to reach the service provider. Service provider generates SAML request, redirect URL, and you can see it go over to the identity provider. Identity provider decodes SAML request and authenticates user. Drop down, SAML response created and signed, and then you can see it pop over here. SAML response returned, user's browser forwards, SAML request verified, and user logged in. Simple Object Access Protocol, a message protocol that allows the distributed elements of an application to communicate in a web services environment. Header structure identifies the actions that different SOAP nodes are expected to take on the message. With its payload structure carries the information. Developers can use SOAP to invoke processes running on different OSs, such as Windows, Mac OS, and Linux, to authenticate, authorize, and communicate using XML. Representational state transfer, considered to be both stateless and separate. Stateless, the server does not need to know the state the client is in, and vice versa. Separate, code on the client can be changed without affecting the server, and vice versa, considering an improvement over SOAP as a means of communication between web-based systems. Software vulnerabilities. An unsecure application can open the door for attackers to exploit it, its data, and even the underlying operating system. Different attacks can be launched using vulnerabilities in applications. An executable files attack tricks the vulnerable application into modifying or creating executable files on the system. Defense: prevent the application from creating or modifying executable files for its proper function. In system tampering, a vulnerable application is used to modify special sensitive areas of the operating system, such as Microsoft Windows registry keys and system startup files, and to take advantage of those modifications. Defense: do not allow applications to modify special areas of the operating system. In process spawning control, the vulnerable application is tricked into spawning executable files on the system. Defense: take away the process spawning ability from the application. All right, so vulnerability description and how exploited. So buffer overflow: a process attempts to store data in RAM beyond the boundaries of a fixed length storage buffer. The attacker can overflow the buffer with a new address pointing to the attacker's malware code. Integer overflow: the result of an arithmetic operation, such as an addition or multiplication, exceeds the maximum size of the integer type used to store it. Tallying the number of items sold could result in a negative value and a resulting negative total cost, indicating that a refund is due to the customer. A memory leak: an application dynamically allocates memory but does not free that memory when it's finished using it. The attacker can take advantage of unexpected program behavior resulting from low memory condition. Pointer deference: a pointer with the value of null is used as if it pointed to a valid memory area. How to exploit it: launching the program by an attacker can cause the process to crash, resulting in loss of data. DLL injection: inserting code into a running process through a dynamic link library. Attacker can use DLL injection vulnerability to cause a program to function in a different way than intended. Addressing software vulnerabilities is difficult because of several factors. Size and complexity: as more features and functions are added, programs become very large and extremely complex. Lack of formal specifications: specifications for a program may not always be in written form and formally communicated, so the work of one programmer may unintentionally open a security vulnerability that was closed by another programmer. That's really easy to happen, especially where you have multiple programmers and they don't put notes in. And especially if the end user, the person that they're supposed to be developing for, have no idea what's actually going on, which is usually the case because they're not programmers. Ever-changing attacks: as attackers continue to create new exploits, it is not possible to foresee all the ways that the code written today could be vulnerable to tomorrow. Software development lifecycle: in recent years, major software developers have focused on improving their software code to increase security and reduce the number of design and coding errors. A software development lifecycle, SDLC, is a methodology for building a program or application from its inception to decommission. All SDLC models include the basic steps of software planning, designing, testing, coding, and maintenance. Until recently, it was a common practice to perform security-related activities only as part of the SDLC testing phase. However, this after-the-fact technique often resulted in many security issues that went undiscovered. Integrating security activities throughout the entire process to form a secure SDLC can help discover and reduce vulnerabilities, often early in your software development. Following a secure SDLC has the following primary advantages: development of software that is more secure, early detection of security flaws, greater awareness of security by stakeholders, overall reduction of intrinsic business risks to the organization, reducing costs due to early detection and resolution of issues. There are several sources of recommendations for secure SDLC best practices. OWASP, which we've talked about a couple of times, the Open Web Application Security Project, monitors web attacks. Materials available: maturity models, guides for development, testing, and code review, and application security verification standards. SANS, Sysadmin Audit, Network, and Security Institute. The company specializes in cybersecurity and secure web application development. Materials available, white papers, research reports, and best practice guidelines. CIS, Center for Internet Security, a nonprofit group that compiles CIS security controls. Materials available, training assessment tools, and consulting services. In my opinion, it's a good idea to use a mix because, as you can see, not all of them have exactly the same things, and you can find different stuff through different ones. They're all really good, but they focus on slightly different things. SDLC best practices that should be used in software development include security requirements definition. The best time to define software security requirements is during the initial design and planning stages. User acceptance testing. An application with a poor user interface, UE, may result in software that is underutilized. It may also encourage users to try to circumvent the security provisions that they find too cumbersome or restrictive, which you definitely don't want because then you're just giving them a reason to try and hack your software. Application stress testing. An application stress test determines if software can withstand the workload placed on it without crashing. Now, there are all sorts of, they have specialty applications and things built just to do this. It's actually pretty cool to watch. Coding secure applications. Developing an application requires several stages. Development. At the development stage, the requirements for the application are established, and it is confirmed that the application meets the intended business needs before the actual coding begins. Testing. The testing stage thoroughly tests the application for any errors that could result in a security vulnerability. Staging. The staging stage tests to verify the code functions as intended. Production. In the production stage, the application is released to be used in its actual setting. Software diversity. A software development technique in which two or more functionally identical variants of a program are developed from the same specification, but by different programs or programming teams. Provisioning is the enterprise-wide configuration, deployment, and management of multiple types of IT system resources, of which the new application would be viewed as a new resource. Deprovisioning in application development is removing a resource that is no longer needed. Integrity measurement is an attestation mechanism designed to convince a remote party that an application is running only a set of known and approved executables. Formal methods for verification of critical software apply mathematically rigorous techniques called formal methods that use tools for the specification, design, and verification of software. Then you have DevSecOps, a specific type of software methodology that follows the Agile model, and you'll hear that a lot, the Agile model, and heavily incorporates secure coding practices and techniques to create secure software applications. Waterfall model uses a sequentially designed process. After each stage is fully completed, the developers move on to the next stage. Then the Agile model is designed to overcome the disadvantage of the waterfall model. Instead of following a rigid sequential design process, the Agile model follows an incremental approach. Okay, I know that's a bunch of stuff, so I'm going to stop for just a second and say, does anyone have any questions? Nope, not at the moment. Anything related to class? It's been recording, Mike, so what do you have? Yeah. You have a question?
Oh, sorry, it messed up where I was like probably messaging German. No, oh no, I was just gonna make a joke saying like, oh yeah, can you start from the very beginning? But never mind.
Okay. Sorry, my sound was turned down there too, so I couldn't really hear you. Okay, so we'll just keep going then. Secure coding best practices. Input validation. All input from every source should go through input validation or assuring that the data received is legitimate. This includes checking for the correct data type, range size, and appropriateness. Output encoding, when displaying dynamic information that was received from any data source, instead of being static information like a label, anything other than the text itself must be stripped away. Parameterized queries should be used when giving input into a database. A parameterized query uses predefined variables or prepared statements as placeholders for parameters. Session management, link both the authentication and access control or authorization, modules that are commonly available in web applications. Data protection, different schemes for securing the integrity of any data that the application accesses. Data protection should be part of the application. All right, knowledge check. Don't be surprised if you can't remember it, because there's a whole lot of stuff I've been throwing at you. Role is removing HTML control characters from the text that is to be displayed on the screen. What secure coding best practice is he following? Display sanitization, output encoding, screen scraping, HTML cleaning. And I will tell you a couple of those are some nice made up terms there. So give me your best shot. Couple more. Come on, you guys can do it. Are you awake? There, we got one more. Okay. Output encoding. I don't feel bad. Like I said, they threw a whole bunch of stuff at you at once. So, okay. So this was one of our tables here. So coding technique, description, and security advantage. Normalization, organizing data within a database to minimize redundancy. This reduces footprint of data exposed to attackers. Stored procedure, making a subroutine available to applications that access a relational database. This eliminates the need to write a subroutine that could have vulnerabilities. Code signing, digitally signing applications, confirms the software author and guarantees the code that has not been altered or corrupted. Obfuscation, camouflage code, writing an application so that its inner functionality is difficult for an outsider to understand. Helps prevent an attacker from understanding a program's function. Dead code, removing a section of an application that executes but performs no meaningful function. Provides an unnecessary attack vector for attackers. Server-side execution and validation, or client-side execution and validation. Requiring input validation generally uses the server to perform validation, but can also have the client perform validation by the user's web browser. This adds another validation to the process. Code reuse of third-party libraries and SDKs. Using existing software in a new application, a software development kit, an SDK, is a set of tools used to write applications. Existing libraries that have already been vetted as secure eliminate the need to write new code, and it kind of saves you time. And if they've already been vetted, especially if they've been vetted by multiple sources, it gives you a little bit of an advantage there. Okay, code analysis. Code analysis involves static code analysis, which consists of analyzing the software from a security perspective before the source code is even compiled. I'm doing great today. Automated static code analysis may also be accompanied by manual peer reviews. And I highly suggest this because, like I've said multiple times, sometimes you just skip over the top of it and you can't see it. Security testing should be performed after the source code is compiled, a process called dynamic code analysis or runtime verification, and when all components are integrated and running. This testing typically uses a tool or suite of pre-built attacks or testing tools that specifically monitor the application's behavior for memory corruption, user privilege issues, and other critical security problems. Software assessment methods. A comprehensive security code review involves running an automated tool followed by a manual analysis to uncover potential security vulnerabilities. Security regression testing is the running of old tests on an application that has been updated and has already passed the test. This is done to ensure that the new software does not reintroduce old vulnerabilities that had already been corrected. Stress testing is a type of software testing that verifies stability and reliability of the software application when tested under extremely heavy load conditions. The goal: to measure the software on its robustness and error handling capabilities when tested beyond normal operating points, and to then evaluate how software works under extreme conditions. User acceptance testing, or UAT, is the final phase of the software assessment process. During this phase, those individuals who will use the software test it. All right, let's see if this is one. Which stage conducts a test that will verify the code functions as intended? Production stage, testing stage, staging stage, development stage. And yes, they did make one of those up. Hope. I think we're forever going to be yelling cope when it comes to these multiple ones, although it does make me laugh every time, so bonus points for that. Okay. Staging stage. Okay, we're going to go past that. Firmware. A specific class of computer software that provides low-level control for a device's specific hardware. Can be found in embedded systems, consumer appliances, computer peripherals, and other devices as well. Held in non-volatile memory that is not affected by a loss of power, as is computer random access memory. eFuse technology is used by a special type of NVM programmable ROM. Typically read-only memory, or ROM, erasable program memory ROM, EEPROM, EEPROM, electrically erasable memory, electrically erasable programmable ROM, EEPROM, and flash memory. Too many letters, sorry. Should only be edited by approved and verified trusted firmware updates. Trusted firmware updates involve secure development, secure update digital signatures, robust distribution, and secure installation. So do you guys know why you should only use trusted firmware updates? You guys should know this. And yes, word's hard today. I think I'm working on a migraine. I'm trying very hard not to get one. But why, for that question, why should you? Yes, but what do you think would happen if, what are some things that can happen if you install untrusted firmware? Yeah, that's true, but I will tell you one of the worst things that can happen is you can absolutely brick a device if you can turn in some of the wrong firmware, just so you're aware. Yeah, you can get viruses, rootkits, malware, but if you have a particularly nasty person and you use a firmware update, you can actually brick your device. Just FYI. Confirm boot integrity. UEFI, or Unified Extensible Firmware Interface, provides several enhancements over BIOS. And I got to tell you, when they came out with UEFI over BIOS, I was super happy. Ability to access hard drives that are larger than 2 terabytes, ability to support an unlimited number of primary hard drive partitions, faster booting, support for network functionality in the UEFI firmware itself to aid in remote troubleshooting, more advanced user interface for configurations and information. Also, when you use the regular BIOS, You had no mouse support. Boot security involves validating that each element used in each step of the boot process has not been modified. Hardware root of trust and boot attestation. Okay, boot security modes. Name, description, advantages, and disadvantages. Legacy BIOS boot uses BIOS for boot functions. Compatible, it better not be compatible with older systems, no security features. UEFI native mode uses UEFI standards for boot functions. Security boot modules can be patched or updated as needed. No validation or protection of the boot process. Secure boot. Each firmware and software executable at boot time must be verified as having prior approval. All system firmware, bootloaders, kernels, and other boot time executables are validated. Custom hardware, firmware, and software may not pass without first being submitted to system vendors like Microsoft. Trusted boot. Windows OS checks the integrity of every component of boot process before loading it. Takes over where secure boot leaves off by validating the Windows 10 software before loading it. And it requires using Microsoft OS as the disadvantage. Measured boot. Computers firmware logs the boot process so OS can send it to a trusted server to assess the security. Provides the highest degree of security, but it could slow down the boot process. Okay, which boot security mode sends information on the boot process to a remote server? UEFI native, secure boot, trusted boot, measured boot. And we just read them, so hopefully you'll remember what it was. Good job. Yep. Measured boot. Processor. Several enhancements to processors that can provide a higher level of security include processor security extensions, provide additional enhancements and reduce the attack surface of the system, trusted execution, a secure area of the processor that guarantees code and data are loaded inside the special secure area, secure enclave, a secure coprocessor that functions in addition to the regular processor, bus encryption, protects the transfer of data between the two processors, atomic execution, permits a processor to read from a memory location or write to a location during the same data operation. Hard drive. Self-encrypting drive, or SED, automatically encrypts any data files stores on it. Hardware secure module, or HSM, is a removable external cryptographic device. An HSM can be a USB device, an expansion card, a device that connects directly to the computer through a port, or a secure network server. Trusted Platform Module, TPM, and you've seen this one listed a couple of times, is a chip on the motherboard of the computer that provides cryptographic services. Endpoint detection and response, EDR, tools that have a similar functionality to a host intrusion detection system, HIDS, of monitoring endpoint events of a host intrusion prevention system, HIPS, of taking immediate action. A sandbox is a container in which an application can be run so that it does not impact the underlying operating system. I absolutely love sandbox environments, especially, I mean, there are lots of places where you're going to see sandbox environments now, so I absolutely love them. Applications interacting with an operating system. Okay, so you got application 1, 2, 3, operating system, files and settings, and then you see down here on the bottom that the operating system is the only thing that's actually working with the drivers and the hardware. This is what sandboxing looks like. So you have your whole sandbox out here with your applications and file settings, and that sandbox talks to the operating system, and then the operating system talks to your applications and files and your drivers and hardware, which is why you can just knock out that sandbox and erase it, and it doesn't have as much effect as it would on the other stuff. Thwarting attacks through port security. Type of attack description, port security defense. Okay, MAC flooding. An attacker can overflow the switch's address table with fake MAC addresses, forcing it to act like a hub, sending packets to all devices. Use a switch that can close ports with too many MAC addresses. So that's how you, that's the security defense, okay? MAC address spoofing. If two devices have the same MAC address, a switch may send frames to each device. An attacker can change the MAC address on her device to match the target's device MAC address. And it's really not that hard. There are tons of programs you can get for this. However, you can configure the switch so that only one port can be assigned per MAC address. ARP poisoning. An attacker sends a forged ARP packet to the source device, substituting the attacker's computer MAC address. You can use an ARP detection appliance to thwart that. Unauthorized packet capturing. An attacker connects a device to the switch's port, and you can get around that by securing the switch in a locked room. So that's why when I talk about physical security, I say it's really important when they talk about network closets. And sadly, I've seen this more times than I care to think about. But there's lots of times when, especially when you have multi-building enterprises where they have locked buildings, and they're like, oh yeah, we've got a network closet, but everyone has a key to the network closet. So it is absolutely not secure. Yeah, exactly. It's called the network closet, not network. Let's store it in the guy's trunk. Yep. But also another thing I've seen is where the network closet is where they store like all of the office supplies. So everybody has access to it, and that's not exactly secure either. Which of these provides cryptographic services and is, remember this, external to the device? TPM, HSM, SEDS, encrypted hardware-based USB devices. Couple more. Okay. Now, technically, they gave you two because technically B and D are the same thing. So that was bad. They're bad. So, okay. Other hardware best practices. Malware signatures, creating malware signatures, identifying and labeling malware code, rule writing, generating signatures according to specific rules, anti-tampering. The different levels and defenses of anti-tampering include the following. Tamper prevention involves making the housing difficult to open by drilling out the heads of screws, using high-strength adhesives to hold the housing together, or applying ultrasonic welding to make the shell difficult to open without noticing damage. I don't know if any of you have any of you seen any cases that look like this? They also have ones where you have to use specialty bits or socket heads and all sorts of things like that in order to get the screws out. It's really interesting to see how they put them together.
So I actually do have something like that.
Yeah.
At the NOS here in Boise, actually USB ports are actually plugged with the normal USB blockers. You need a special kind of like little, I guess, key for it to actually like you got plugged in and pulled out.
Right. Yeah, that's an excellent example right there. Yeah, they have those for like all sorts of different ports too, but especially for USB devices. Tamper detection, anti-tamper switches, sensors, or circuitry can be added to hardware devices to detect tampering. Tamper response. If tampering is detected, the device can be programmed to shut down, erase critical parts of memory, or physically destroy the entire device. Trusted Foundry. This is a program by the U.S. Department of Defense that is designed to secure the manufacturing supply chain for vendors who supply technology to the military. It provides a cost-effective means to assure the integrity and confidentiality of integrated circuits during design and manufacturing. All right. All right, so that's it for today for that slideshow. So that was an awful lot of high, what do you call it, vocabulary content. I'm going to stop the recording here.